So here we have the graph of y equals to x to the 6th power minus 10x to the 5th power, blah, 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 blah. And this right over here lies above the line y equals to bx plus c at some values of x. When we were asked for the largest values of those x intersection points with y equals b to the x plus 3. Now I forgot to write this, but this is 2010 AMC 12, question 21, set A. So after knowing this, we can determine that. So first, if we're looking at these values, x to the 6th and x to the squared. So x squared is definitely going to be left out. But afterwards, we were going to have an x to the 4th power. Now, being determination of these squares, we can determine what this graph exactly is. So, after looking at some stuff, we can determine that, first of all, the x values in these things intersect at these lines at the same zeros of all of them combined. So, we can just add bx plus c. Minus bx minus c over here. So we can have y equals to x to the 6. So if we combine these two equations and we subtract one from the other, we can have this equation instead. And this is just basically what we are looking for, which is the intersection points. And by the x theory we talked about earlier, we do know about both of the graph's lines, which can help us with this equation. So since this equation has 3 zeros, as told us by the problem, and the functions are never negative, all 3 zeros must be double the root, because the function's degree is 6. Suppose we let p, q, and r be the roots of this equation. X to the 3rd minus, we have ux squared plus ex minus w. So this is going to be the equation of which these intersect. And p, q, and r are going to be the roots of this cubic polynomial. So we can simplify this to be equal to x minus p, x minus q, x minus r. And these two are equal to each other. So if we were to look at this equation and we were to square it, we would have this. Now let's just pretend that, for example. So p, q, and r are the 3 roots. They form this equation, and if we square this equation, we are looking for this. Now this is a strategy. This is not really a method. This is just for this problem only. So we square root this big giant equation, and we will have x to the 3rd minus ux squared plus bx minus w, and that everything equals to 0. So now that we know that the square root of this equals to this, we can move on to our next step. So we can simplify this equation. We can take the square root and square this section. Now know that I'm not writing much because it's going to be very difficult to write down every single thing. So if we square this side, we can have x to 6 minus 2x to 5th, blah, 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 blah. I will not be simplifying everything, but just note that that is this equation squared. So since we don't really know a, b, and c in this equation right over here, since we don't know a, b, and c, we really don't need the last 3 terms of the expansion. So after looking at everything, we can factor everything out. 1 to 1, 2x as 10, and then we can continue from there. So, sorry, not 2, wait. This is going to be 2ux to the 5th power. So 2u would match up to negative 10, and then so forth and so on. So we'd have negative 2u as negative 10, blah, 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 blah. And after you simplify everything, you can determine that u equals to 5, v equals to 2, and w equals to negative 8. So after knowing this equation, you can plug everything back in. And after you simplify everything, you can determine that the total biggest root of this equation, when plugged in with the values, is going to be 4. Now note that I did not write very much because it's going to be very tedious, but this is just a very simple equation and a very simple understanding to know how to do it.